Hello and welcome back to my channel. Today we are going to develop a code of Newton-Raphson method, which is considered to be the most fastest method for the solution of nonlinear equations because its rate of convergence is 2. So for the development of the code, we need the following thing. So initially we need to define a nonlinear function and its derivative. So we are considering a function that is f of x is equals to x cubed minus x minus 2, which is a nonlinear function, and after that we will use its derivative also. Then we are going to set the initial condition to 1, that is x naught is equals to 1. After that we will apply the Newton-Raphson method to find the root, and for finding the root we need to apply the while loop in that code. After this we are going to check the convergence based on our tolerance, that is 10 raised to the power minus 6, or a maximum iterations. Then we will plot our function, and after plotting the function we will display the final roots and result onto that function. So let's proceed to the MATLAB. So this is the interface of the MATLAB, and we are creating our code in a script. So we just click on a new script and an editor open in front of us. Now we are going to start developing our code, that is of a Newton-Raphson method. So we are going to start with the CLC, clear all and close all. After that, we need to define our function and its derivative. So our function is f is equals to at the rate x, and we choose x raised to 3 minus x minus 2. And according to this, we are defining the derivative, that is at the rate of x, and our derivative would be 3 static x h square minus 1. So this is basically our function, and this is derivative. Okay, after that we set the initial guess, that is x naught is equals to 1. That is basically our starting guess. After that we are going to set the tolerance, that is 1 e raised to the power minus 6. That is basically the stopping criterion for accuracy. After that, I'm going to define the maximum iteration to 100. That is basically the maximum number of iterations. Okay, after this, I am going to initialize the variables. And for that, we have x naught and iter is equals to 0. After that, I am going to start my iterations for the Newton-Raphson method. So for that, I'm going to create a loop. So Newton-Raphson iteration loop. So here I am creating a while loop, and we can create both while loop and for loop, both are applicable, but I am creating this code with the help of a while loop. So iter is less than max iteration, and I'm going to write the end, and then I'm going to work in between. So first of all, I'm going to compute the next approximation by using the Newton-Raphson formula. That would be x new and then x minus f of x divided by df of x. After that, I'm going to check if the solution is within the tolerance or not. So check if the solution is within the tolerance. So for that, I am writing an if statement, that is ABS, and that is absolute. So x new negative of x, that is less than tolerance. And the print, so we write f print f, that root found at x is equals to percentage dot 6 f. So we choose a tolerance till raised to the power x, so that's why I used 0.6 decimal places data. After percentage d iterations dot backslash and n, and after that I want to see the result of x new and then iter plus 1. When it reaches, so it breaks the code, and after break I have to end it. After that, I want to update the current value of x and the increment iteration counter. So for that, I am using, so update the current value. So for that, I am using, and plus I also want to increment iteration counter. So for that, x is equals to x new and iter, that is equals to iter plus 1. So after that, I am going to end my while loop. So after that, I am going to check that if the method converge within the maximum iteration, or it will exceeds the number of iterations like this. So for that, I am going to, if the method did not converge in the given iterations, so I need to update it. So that is basically for the checking criteria. If the method did not converge within the maximum iteration, so if iter is equals to max iteration, and I'm going to end it, and in between I'm going to write fprintf. So they gave us a message that method did not converge after percentage d iteration, that represents the number of iterations, dot backslash n, and they gave us the value of maximum iteration. After that, I'm going to plot my function and the root. So for that, I am plotting the function f of x. So we have x values, that is equals to linspace, and I'm starting from -2 to 2 and setting to 100. And after that, I'm going to define my y values with the array function, and for that I'm using function and x values that will basically evaluate f of x at the points in x values. After that, I want to open my new figure and I want to plot x values versus y values, and I want to define the color and style. The color is red and the style is straight line, solid line. And after that, I'm going to define my line width that would be set to 0. You can change according to your choice. That will plot f of x. After that, I want to use the hold on because we want to plot the root onto that function also. So next I am going to plot the root. So for that I use the word plot. I have x new and then f of x new. Then I have a color blue and the style O. As I am using a style circle, so I use a marker size here. That should be set to 10. You can change this according to your choice. After that, I'm using a marker face color to blue. That will plot the root onto the given function. Okay, after that, I'm going to set my x label to x, y label to f of x, okay, so after that, I want to write the title, that is a Newton-Raphson method. Then I want to write the legend. So my first is f of x and the second one is of root, and finally I want to on my grid. Okay, let's run it. So that's how we can develop a code of Newton-Raphson method. This is the root that we found after 6 iterations, and that is our graph. That is a Newton-Raphson method. This is the graph of a function, and this blue dot represents the root that lies somewhere here on 1.52138. If you found this video helpful, give it a thumbs up, subscribe to more MATLAB tutorials, drop a comment if you have any questions or suggestions for the future videos. So thank you so much for tuning in and take care.